Physicist Enrico Fermi once asked, "Where is everybody?" Meaning, why haven't we seen evidence of other life forms? The Fermi paradox describes the lack of evidence of extraterrestrial life and the high probability of its existence. The Drake equation addresses this by multiplying the number of life-bearing planets by terms outlining criteria for intelligent life, currently unknown. The Great Filter Theory attempts to explain the unsolvable nature of this equation by stipulating that something is filtering out the possibility of extraterrestrial life. Some theories for what this filter may be, based on terrestrial biogenesis, will be discussed next.
Evidence today supports life arising quickly and easily on Earth, suggesting Earth-like conditions alone may allow biogenesis. Key markers of biological prehistory include the moon-forming impact and the late heavy bombardment, followed by the domination of single-cell life and eventually the Cambrian explosion. To identify life's impact on Earth, paleoecologists rely on biomarkers and direct fossil evidence, such as environmental impressions, biosynthetics, and isotope fractionation. These same techniques can be used by astrobiologists to scan inorganic structures on other worlds. Assuming basal life characteristics must be ubiquitous, a few key requirements arise. Key physiological traits include energy use, environmental impact, and self-reproduction. Evolutionarily, all life is subject to natural selection, dependent on inherited regimes. Biochemically, nucleotides and amino acids must be present, with an overall aqueous biochemistry. Taken all together, the Earth's paleoecology and geological history stereotype the origin of life on our planet, which may allow us to extrapolate processes regulating life elsewhere.
There are three prominent theories for why we haven't heard from anyone else. 1, that we are alone, life is possible, but we are the first. 2, we aren't alone, but won't know it. This could be due to extraterrestrial civilizations, lack of resources, or lack of desire to communicate. Some posit that the desire to explore may be unique to our species. Alternatively, civilizations self-destruct before they reach the stage of exploration or communication, and we will never know of their existence. And the third theory states that extraterrestrial life contact hasn't happened yet, but can.
Having described life's history, we now return to its terrestrial birth. A spontaneous beginning of life out of an originally inorganic RNA world is possible. However, so too is panspermia, wherein life was introduced to the world from the ejecta of another. Documented conditions and life forms suitable for this crossing lend credibility to the idea and have encouraged NASA to mitigate the threat of directed panspermia. The hesitancy to introduce terrestrial biology into foreign ecosystems mimics that towards backwards contamination.
On the working assumption that there is intelligent life, it brings us to the question, what should we do about it? Encouraged by environmental degradation, we've looked to the stars for a new home, theoretically with new neighbors. Perhaps, first, there are a few questions we should ask of ourselves. As said earlier, one explanation for lack of extraterrestrial life could be its self-destruction before being able to communicate. Through climate change, are we facing the same fate? How would other intelligent civilizations respond to similar issues?